Hello everyone, I'm Solar and this is Solar 3D Studio channel. This lecture is about investment casting of a mechanical metamaterial, which is actually a modified version of TPMS primitive lattice structure, which you already seen in the video. This video is actually a reproduction of my last investment casting tutorial, which sadly has poor quality, and some subscribers asked me to reproduce it. I think it's a more advanced structure, which you can see compared to that structure, and actually the whole process and the base and foundation of the simulation is the same like the previous version, which you can have the link to that tutorial in the captions. So let's enjoy the simulation in a more complex way with a more complex structure. This structure came from one of my articles, which you can find the link in the caption, which I produced a mechanical metamaterial through investment casting and investigated the mechanical characterization of this structure, which you can read and learn and share your thoughts about the article or the simulation in the comments below. And here is the previous tutorial, which sadly had poor video quality. So again, the outcome is the same, the procedure is the same, but we are going to work on a more complex structure and geometry. So let's start the simulation. Okay, as always, we start with visual mesh, so we need to import the model that we created in SolidWorks. So let's go to the file menu and use append. And here is my model. Okay. Great. Here is my model. Okay. As you can see, I have attached the runner to the lattice structure. So let's just check the model, no problem. And now we could apply the surface mesh to our structure. I think element size of 1 is too small, and it could cause a massive amount of calculation. So I'm going to use 5 instead of 1. So I applied a mesh. It seems that it is a good mesh, so let's just check the surface mesh. And surface mesh is okay, hopefully. So in terms of doing investment casting simulation, you need to create and prepare a shell as a mold, which we actually call it refractory alumina in real world, and we are going to assign this material to the shell part in the simulation too, but we couldn't import and create the shell in SolidWorks or different kind of CAD software, so we need to create the shell in ProCAST software. So we will go to 2D mesh, and it's important to know that you need to do this. It's not something you forget, it's part of your simulation. Many ask me that is it possible to don't do this or replace it with something? No, it's a must in your investment casting simulation. I know it's very difficult to find the optimized version of your actually shell, but you have to do this. Okay, let's go to 2D mesh shelling. You can say yes. You change the type to uniform thickness. You need to go to the no shell phase, click on modify, and choose this opposite side of your runner to avoid creating a shell around it. Okay, here in this section you will create the thickness. I think 1 millimeter is good for my structure. Let's just see together. It's pretty good. And let's just create it. Okay. Here's my shell, and the green part is my part, which is actually a combination of runner and lattice structure. So let's just create the volume mesh. As you already know, this is a complex simulation, so you need to know that it takes time for meshing or for simulation or things like that. Okay, let's move to the next part, which is the visual cast. When you open up your visual cast, this is the first question that software wants you to answer it. So you need to define the gravity vector, which is actually the -y for my model. So I apply it, everything is okay. Let's move and define step by step the conditions and the nature of our simulation. Okay, first volume manager. The first volume is my lattice structure. The second is my mold. Great. The lattice is alloy, and the material is copper C95 300. Okay. The initial temperature is 25. Note this: your alloy material in investment casting has a room temperature as the initial temperature. Okay, for mold, we choose mold, and we need a refractory alumina, and the initial temperature is 800. This is the nature of investment casting. As far as I know, we always have preheated molds in investment casting, so you could change it based on your preference and your problem, but in any cases that I have worked on, we always have preheated molds. Okay. We are finished with volume manager. Let's move to interface, which is a coin with the H of 500. Great. Let's move to process condition manager. We have three condition or boundary conditions here: 1 heat and 1 inlet and also 1 valve. Let's define this carefully and accurately. Okay, the heat is, as you may predict it, is for external mold, and you're right, this is an air cooling type of heat. For inlet, we need to choose it. Okay, I think circle and 13 would be good. Let's see in everything. It's too small. 15 is better. Okay, apply it. Here is my inlet, and this boundary condition is proper for my simulation. Now let's talk about the valve. Actually, valve is something in between the lattice structure external surface and the internal surface of your shell. So for this, we need to go to part and hide everything except lattice structure. We go to the valve and we change the type to element face. Just drag and select everything. Okay, as you could see, just drag and select everything to element face. Hold down the shift button and use this. Hold down the shift button and deselect this surface. Okay, apply it. Great. You could turn on everything again and apply it. We're finished with the process conditions. We also set the gravity vector. Let's go to simulation parameters, change it to investment casting. Okay, apply. And data check and run your simulation. I will come back with the results. Okay, the simulation is finished. So let's see the result and enjoy this simulation. It's a complex yet simple simulation. It's not at beginner level, but it's really easy if you understand the nature of it. So let's just hide the mold, see how it works. Things could be improved, but I'm already happy with what we've done. So let's just see the fractions of it to see if it's working right or not. Okay. Let's see if it's cooling like an investment casting or not. Actually, it is. As you can see here, the struts are cooling from the outer shell, so it means that investment casting are working well in this simulation. Thank you so much. Ask your questions on the comments below. Do not forget to subscribe, turn your notifications on, and like this video. Also, you could see the previous version of this video from the link in the caption. Thank you so much. Have a nice day. See you in new simulations.